We have to wait a moment, just 2 seconds. Okay, now the lecture is being recorded, so very nice. And now I will share my screen with you, my tablet. I hope everything will be okay. Can you see the presentation now? Please confirm.
In my case, it's still loading. I see a black screen.
Yeah, it's still loading.
Yes,
now we can.
Yes.
Oh,
we can
so
see.
after a moment you can see. Okay, so now I will switch off the camera. I told you internet connection today is pure very weak, so I disconnect the camera, and hopefully the quality of our lesson will be satisfactory. What do I want to start with? Probably you remember we took last time a task, calculation of grain stability, and we took an exercise with numbers, and I in the meantime honestly 5 minutes before our lesson started, I took computer program. I hope you have access to this computer program, and I put the numbers by keyboard, and now you can see the results of calculations. And honestly, I cannot remember correctly what number we received during our calculations at classroom, but now you can see variables and values given by computer program. It seems to me that somebody of you calculated the angle of hill, which was caused by shifting of the grain, and the result of calculation was bigger than 12 degrees. So the computer says the same number. Please confirm my recollection is correct. The result of your calculations.
Yes, sir. The exact same degree, 12.1.
12.1. So that person or those students, because probably there were more students than one, who calculated 12.1 or almost 12, yeah, something like that, more or less 12. They obtain the same result as computer said. And if I remember correctly, somebody calculated area and the result was 0.2 and something, and another student calculated area and his result was 0.1 and something, of course in meter radian. And if I remember correctly, I told you that I didn't like number 0.2 because I thought it 0.1 will be correct, but I have to say that I was wrong. That student who told me his grain area between writing cleaver curve and healing cleaver curve was 0.2 and something. That student was correct. Can you remember who said 0.2? Please remind me.
I think Roman said so.
It was me, Dennis.
Dennis, okay, Dennis. All right.
It was me, so it means who? Because still I don't know.
Dennis Sarancha, sir. Dennis Sarancha.
Dennis Sarancha obtains this result. Okay, so congratulations. Your result was correct. And I really don't remember what was the result with regard to initial metacentric height. The computer says 1.9 and something. Please confirm or say your result was the same or different. I don't remember
Yes,
that
it
number.
was exactly the same.
Exactly the
Yeah,
same.
it was
Fine. Okay. So you can see results given by computer program, and you can compare your results obtained by hand calculations, and see and can compare, yeah, who was right, who was wrong. If I may suggest something, I would encourage you to use this computer program in the meantime to different calculations, not only for carriage of grain in bulk, but also other calculations and see what happens with bending moments, what happens with shear forces, what are the results of different calculations in terms of foredraft, aft draft, mean draft, and so on, and see the tendency, what will happen if you change, for example, position of the center of gravity, or if you fill in a ballast tank, let's say in 50%, what will be free surface correction, what will be final vertical position of the center of gravity. I would encourage you to use this program. I did put that program in Moodle platform last time during the first week of our lectures, so you can use it just for your experience, to gain additional knowledge and observation, and to make your skills more general. This is my hint, this is my suggestion what to do. Okay, if I remember the discussion, there was a moment of the discussion, what shall be done to have all the criteria satisfied, all of them, so including this hill caused by shifting of grain. And it seems to me Batuhan had a proposal. Batuhan, could you repeat what was your idea? What shall be changed in the loading condition to have all stability criteria satisfied?
In this example, our all ballast tanks are already full, so we cannot take any ballast, so we should take more grains, more cargo, so that the movement of the grain will be less, as the cargo hold has more grain inside in it. Empty space will less, so movement is less, so the healing moments also will be less.
Okay, so yes, please continue. Please continue.
As I said, if we have available ballast space, we can take ballast water at the double bottoms, so that the GM value will be get lower. The kg will be get lower, so the GM will be higher, so that the also healing moment will be less.
Okay, so to sum up, what did you say? You considered two options. The first option was ballast water into a double bottom tank, and the second option was more cargo into the hold. And your summation was that the first option will not work in our case. It is general, of course, but in our case it will not work because all ballast tanks are full. Am I right?
Yes, sir. As we check the loading condition of that vessel, at that weight, at that displacement, our all ballast tanks had already been full.
So general idea is correct, but in our case, it may not be applied. Yeah. So the second option was to get more cargo, and if I remember, you checked that if there is more cargo, volumetric healing moment goes down. Yeah.
Exactly.
In the table.
Yes.
If volumetric healing moment goes down, it means that lambda O and lambda 40 go down at the same time. Yeah. So new healing curve will be like that. Can you see? Please confirm you can see the new healing.
Yes, we can see.
So it will be healing arm. Okay. So if volumetric healing moment goes down, lambda O, lambda 40 goes down at the same time, but more cargo means also bigger displacement. If bigger displacement, maybe, I'm not sure, but it might be that right-in-cleave curve will go a little bit higher. Yeah, go a little bit higher. If so, the angle of equilibrium. The angle of equilibrium, I will take green color, will be in new position. Let's say it will be 6 degrees. And area will be a little bit bigger, taking into account this additional area. Maybe the color is not correct. Maybe I shall use another color like gray. Okay, additional area, and at the same time the angle of heel will be smaller because VHM, volumetric healing moment, goes down. If we take this opportunity to observe the tendency, the volumetric healing moment, how does it relates on height of the cargo. Here is height of the cargo. Let's say it is maximum height of the level of the cargo in a hold, and here is VHM, volumetric healing moment, of course given in meters to force power. The relationship between level of the cargo and volumetric healing moment is something like that. This is average function for average ship. So if the volume of the cargo is bigger, probably the volumetric healing moment will be lower in this range of feeling of the hold. So Batuhan, you were in 100% correct, and also other students who thought about such a solution were right. Yeah, it would be the best solution in this particular case. Okay. Before I will start new topic, maybe there is a student who wants to ask additional question just to complete carriage of grain in bulk. I open the floor for your questions. Maybe there is a need to ask, and I am ready to answer the question.
Hello, sir. I don't have a question, but I don't really understand the Batuan's method that you were explaining. I don't understand the difference between this method and the method Batuan proposed. If you can explain again or throw more light into it.
I'm not sure I understand you correctly. Are you talking about two options, option number 1 and option number 2, and the difference? Am I right?
Yes, I don't understand the difference. Can you please explain?
Okay. So I need additional slide. Click. It is, and I will try to show you how I see the case. Here we have our ship. Here is aft bulkhead and fore bulkhead of our hold. Here is engine room, double bottom, and here was frame number 25 and frame number 111, and space between those two frames was available for the cargo, and the cargo was filled in with grain in bulk to some extent. Oh, I cannot remember how much, maybe 60%, maybe more, but let's say there was a cargo like that to some level. It means level of cargo is like that here, and h that I put here in this very small drawing, h, this is the distance between the tank top and click. Now it shall work. Okay. between the tank top and the level of the cargo in the hold. It was H. And relationship, you have to imagine this is a surface. This is the first surface of the grain cargo. From port side to starboard, from aft bulkhead to fore bulkhead. And volumetric healing moment as a function of filling of the hold. The function is like that. Here is filling of the hold, maximum. Let's say we are at the level of, let's say, somewhere here, let's say 60%. And this function, usually, in general, for average ship, this function is something, looks like such a curve. Such a curve. If the filling of the hold is small, the volumetric healing is small, somewhere, let's say more or less 50%, the volumetric filling moment is the biggest one. And then when you are close with your surface to the deck, here actually it is deck. When the surface is closer to the deck, the volumetric healing moment decreases. Okay, in our case, all ballast tanks, double bottom ballast tanks, were filled in, and probably somewhere here we have fuel oil also in double bottom tank. It is my imagination of the situation. Okay, and the result of our calculation was that the angle of heel, which is caused by shifting of the grain, was bigger than 12 degrees. And it means that this criterion is not satisfied. And the question was what to do to change somehow the loading condition in such way that the heel caused by grain shifting will be smaller than the minimum, than the maximum required as a standard here. Yeah? This was the question. What to do with the loading condition, with the view, with the goal to make healing heel angle caused by grain shifting smaller than 12 degrees to satisfy this criterion. And Batuhan and other discussed about two options. The first option was to decrease position of the center of gravity by filling in double bottom tanks, ballast. But Batuhan said that all ballast tanks are filled in 100%. So there is no space here to fill these ballast tanks. And this is the reason why we deleted this option from our list. It is good idea if you want to make vertical position of the center of gravity lower. It is good idea to fill in double bottom tanks, but it was not possible because double bottom tanks all were filled in 100%. And the second option, Batuhan said, was to load more cargo into the hold, more grain cargo into the hold. For example, to achieve such level. Okay, additional cargo. I will put which color. Let's say it will be such color. Yeah, additional cargo. And where is the advantage? Where is advantage doing so? Advantage is that if the height of the cargo level is bigger, yeah. Here we have yellow height, and now I will change color to which one? Maybe this one. Now the height of the cargo is bigger, is new. So volumetric healing moment, this one, is smaller than volumetric healing moment for previous position of the surface of the cargo. VHM, which is pink, is smaller than VHM, which is yellow. Yeah, and if you remember, I hope everybody does, everybody remembers, lambda O, so healing lever caused by grain shifting is calculated in such way. Maybe somebody will tell me, I don't remember what is the formula, how we calculate lambda O, healing lever caused by grain
Sir,
shifting.
it's VHM multiplied by stowage factor, yeah?
Not stowage factor,
Specific
By
weight,
specific weight
Displacement.
over displacement.
And divided by displacement.
and divided by displacement. Okay, so this is the key here. Yeah, if we want to calculate lambda O, this is that value. This is lambda O. We want to have lambda O lower to decrease the angle of heel, the intersection between the straight line lambda O, lambda 40. Here is, lambda 40, this distance here, to have smaller angle of intersection between the straight line and GZ curve. Okay, so coming back, lambda O can be calculated using this formula. Somebody, probably it was Batuhan, started with stowage factor. Stowage factor shall be here if you want to use stowage factor. Batuhan, am I right?
No, sir, I said it.
I'm not sure.
I said it, so still I don't know who. There are two possibilities.
Mikhail. So it should
Mikhail.
be below VHM.
Yes, stowage factor, it is 1 over specific weight. Yeah. Okay, so you have to use stowage factor below VHM, or another option, use specific weight here. Yeah, so it is the same. Yeah, it is the same. And what was the idea by Batuhan? Okay, if you load.
Yes, if we load the grain, the VHM will decrease. Also, the displacement will increase. So
Yes,
lambda 0 will be changed actually logarithmically, not.
maybe not logarithmically, but will change. Yeah, because you don't know what is the function here. Yeah, what is the shape of this function. But in general, volumetric healing moment decreases if you load more cargo in this range here, yeah, in this range. So it goes down. Gamma is constant value. The specific weight still is the same, and displacement goes up. So lambda O goes down rapidly. I think rapidly it is better than logarithmically. Yeah, rapidly
Yes, sir, I
goes
just
down.
cannot remember the exact words, so
Fine.
that's why I use
Okay,
that.
so if lambda O goes down rapidly, it means that the relationship between healing lever and righting lever changes in that such way that angle of equilibrium, the angle of cross-section of both levers, will be smaller. Yeah. So we discussed two options. The first one, ballasting. The idea was to at the same time increase the displacement and decrease position of the center of gravity. But this option was rejected because there is no space in the bottom. The second option, load more cargo. Then you have two advantages. The first one and the second one. And lambda O goes down. Now I turn to God's power. Did we answer your question?
Yes, sir, it's understood. I understand the reason why cargo is increased. It makes sense.
Okay. And hopefully it was your question previously, yeah? Am I right?
Yes, that was the question. I did not understand it because now I have a clearer picture, so I could picture it appropriately. I understand what you're talking about now.
Super. And God's power, thank you for your question because it is very, very valuable. I usually think that if one student asks a question like you did, probably there are other students in a group that would ask the same question, but you are, how to say, brave or braver than others. Yeah, so you ask the question on behalf of other students who didn't catch the point. Thank you very much for doing this because I hope it put new light on the problem that Batuhan proposed during the laboratories. And if you understand now, so it is okay. It is fine. It was the purpose of this part of the discussion. Okay. Are there any other questions with regard to grain stability, grain criteria?
Yes, sir. I have like question about so our VHM decreases and our displacement increases, but to obtain like the lower L0, we should have like more significant change in VHM. Yeah, how to say it? Because like VHM decreases, but displacement increases. So, but VHM is more significant here. Yeah, it's like my question.
Actually, I don't understand the point because it seems it is obvious that if VHM decreases.
Yes, sir. Because if displacement is bigger, then L0 is smaller. Yeah, of course.
Yeah.
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 Okay. So, okay.
Fine. The most important is that you divide by displacement, yeah? Actually, I could put here, if we use abbreviation from taken from laboratories, here should be D prime, yeah? It is actually D plus additional weight of cargo, yeah? So yes. the displacement increases in this meaning that if you have additional piece of cargo, additional part of cargo, pink, so the total displacement is bigger. If total displacement is bigger, the healing lever is smaller. Yeah. The healing lever is smaller. Maybe if I put from the very beginning P plus D, P it means weight of additional cargo, it will be more clear. Yeah, maybe if I did it on the very beginning, it would be more clear. Okay. I am looking to the clock, half of an hour passed, but I think we didn't waste time. If we ask the question and answer the question, it is okay. I am back to the idea. I really encourage you to make your own hand calculations. If you didn't manage to finish to complete during labs, just and to compare your results, your private results with the computer program, just to gain experience and additional skills to calculate different parameters of stability. All tables you need were submitted to you during the labs. So all data for calculations are available for you. And once again, I encourage you to complete the calculations if you didn't manage to finish during labs. Okay, so what next? We start new problem, dealing with new problem. And what is problem about? Grounded vessel. New topic, very fresh for you, grounded vessel. And the first step will be calculation of the reaction force between the hull and the ground. What was the reason of grounding? It doesn't matter during our classes. Just there was a reason, navigational fault, I don't know, malfunction of rudder, anything, and the ship is grounded. There is a contact between the ground and the hull. So additional force acting on the hull. If you consider the third semester, we usually say that there were two forces acting on our ship: weight related to gravity. The second force was displacement related to water pressure acting on hull plates. And now we have the third component, reaction between the ground and the hull. So there will be three forces acting on our ship: weight, as it was, displacement, and reaction between the ground and the hull. Additional force. It will be the problem. And calculation of such variables like position of the center of gravity after grounding, initial metacentric height after grounding, actually what is the force, what is the point of action of such force. So I will put here xp, yp, zp as a coordinates of point of action of additional force, and other variables which will be interesting for us. What to do, what to calculate after grounding of the vessel. Before we start the topic, I would like to make some refreshment. What knowledge do you need to know before you listen to this lecture, before we start consideration of the grounded vessel in terms of additional force acting on our ship? And I put here a list of this knowledge, of points, yeah, of this knowledge. Degrees of freedom of the ship. There are three degrees of freedom considered during our classes. Who can name such degrees of freedom? If we are talking about 3 degrees of freedom, so what are the names of these degrees of freedom? Who can remember? The ship has stability in 3 directions. The first one is draft. The second is trim. And the third one? List, the angle of heel, or list. Fine. So 3 degrees of freedom. We will be considering drafts, trim, or change of draft, change of trim, and change of angle of heel, or in other words, list. I would prefer considering grounded vessel and external force for the ship, external force reaction between the hull and the ground, to use word heel instead of list. Okay. The next portion, the next set of information is what does it mean TPC, what does it mean MCT, and what is GM, and what is the application to ship stability assessment. If we calculate ship stability, what TPC, MCT, and GM may be used for. And let us start with TPC. Who can remember what does it mean TPC, and what will be the application of such a variable TPC? Who can remember and who wants to refresh memory? What does it mean TPC? Tons per centimeter.
Tons per centimeter.
And what is the meaning of a number? What is the meaning of a number? For example, TPC is equal to 40 tons per centimeter. What information is contained in such a number?
That there is the force of 40 tons on 1 square centimeter.
Not square centimeter, just centimeter.
This
Yeah?
value tells us how much weight we should add to change our draft by 1 centimeter.
Yes, that's right. Fine. I will change color to green. MCT. What information is included, is contained in MCT? Moment to change trim. MCT, moment to change trim. Let's say 50,000 tons meter. What does it mean? How can you understand, how do you understand such a number? For 50,000 tons meter. What does it mean?
How many weight is needed to change the trim by 1 meter?
More exactly, not only weight. Not only weight. Yeah. If I take, for example, 500 tons, and I move 500 tons per 100 meters, it means that I act on my ship with trimming moment equal to 50,000 tons meter. Am I right? If I shift 500 tons over the distance 100 meters, at the same time, I provide trimming moment.
Yes, sir.
Yeah.
Yes, you are right.
Okay. So this information tell us what moment shall be used to change trim per 1 meter. Yeah. What moment shall be used for our ship to change trim per 1 meter? This is the information. And maybe it will not be surprising that GM, the third degree of freedom, GM, it is the distance between so-called metacentric point and the center of gravity. And GM is used for which purpose? For calculation of the angle of heel, or sometimes change the angle of heel. And I will change color to red now. Red, okay. And put here in red color KM. So I have three variables: TPC, MCT, and KM. Who will answer the question? If you are on board a ship and you need such variables for your calculations, where is the source of data? Where can you find such information like TPC, MCT, and KM? Tons per centimeter, moment to change trim, and vertical position of the metacentric point. Where is the source of data? It should be obvious for everybody. Who will tell?
You can find this information in the hydrostatic particulars.
Hydrostatic particulars. Sometimes during our lectures we call it hydrostatic tables. Yeah, tables in digital form, maybe sometimes particulars in the form of drawing. Okay, but we use both names: hydrostatic particulars or hydrostatic tables. So if you need this information, the information is available on board your ship in hydrostatic tables. And hydrostatic tables, it is one part of, in general, ship documentation, at least from our point of view. Okay, fine. And the last step of our refreshment is we need to define methods in terms of formulas, how to calculate change of mean draft, change of trim, and change of the angle of heel if weight, let's say weight like this one, has been loaded on board the ship in known position. So XP is known, how far is the weight from aft perpendicular. YP is known, how far is the weight from the central line, and the last variable, let's say I will put here ZP. ZP, it will be information how far is from the baseline to the center of gravity of this additional weight. Yeah. Okay. ZP is also known, and the ship will move in 3 directions as we said. Yeah. After new weight has been loaded, like P, the ship will change draft, the ship will change trim, and the ship will change the angle of heel. 3 degrees of freedom in our subject. Okay, and now I need you, I want you to provide me the method of calculation of change the mean draft, change trim, and change of the heel if additional weight P has been loaded in known position XP, YP, and ZP. Who is brave enough, who remembers correctly the method of calculation, change of mean draft, change of trim, and change of the angle of heel? I open the discussion. Here we have initial waterline, and here we have final waterline. Change of trim will be probably okay, I cannot show change of trim. It is too complicated, so I will delete this. Fine. I open the discussion. In the meantime, please tell me what will be the method of calculation. Change of mean draft, change of trim, change of angle of heel, caused by additional weight loaded on board. Position of this weight is known. XP, YP, ZP. For a moment, I will turn to you. Okay. Who is brave enough to answer the question? It should be obvious for everybody. I think almost everybody knows how to calculate change of mean draft, change of trim, and change of heel when additional weight has been loaded. Okay, so I encourage you to provide me the formula. Who is the best student? Okay, so I turn to the list.
Sir, I can try, but can you repeat the question?
The question is the method of calculation. Change of mean draft, change of trim, and change of the angle of heel after additional weight P has been loaded into known position. The position is described by XP, YP, and ZP. How far is the weight from aft perpendicular, X? How far is additional weight from central line, Y? And how far is additional weight from baseline, Z?
We are just shifting the weight has already on board, right?
No, It is additional weight. Additional weight. It is not shifting existing already, but new one, new additional
About
weight.
the change of draft, we should know the ship's geometry also, probably, because for each, or we can just use a ton MTC, ton per
TPC.
centimeter, TPC, sorry, TPC, ton per centimeter.
So can you provide the formula?
Okay, but I need to check. Can I think for 1 second? Yes, exactly.
There is nothing to check. If you really understand the idea of TPC, what does it mean? Yeah. If
Yes,
you
now
really
I'm just
understand.
writing on paper that the unit of the TPC, and
Okay.
then I will.
If you know the definition, this formula shall be obvious. Yeah.
Yes.
P divided by TPC. And what is the role of 100 here?
To change in centimeters to meters.
Yeah, if you multiply TPC by 100, the result, the final result of your calculation will be expressed in meters, yeah, in meters. If you did not do it, the final result will be in centimeters. And we, of course, prefer meters as the final result of calculations. Fine. So this is the first degree of freedom, change of mean draft. And I believe that everybody who sat silent during our conversation with Batuhan, everybody is shamed that he didn't answer such a simple question. Yeah. Okay. If you really don't remember the idea, the method, it should be your homework for this week or for the next week, just to be on time before the exam. Yeah, during the exam, probably it will be simple exercise, simple task to do. Calculate change of the trim, change of the draft, if additional weight has been loaded on board the ship. It is one of the exercises which should be easiest one for you. Okay, so next degree of freedom, change of trim, rotation. The pivot point here is F. This is the center of flotation, yeah? The center of flotation, it is the pivot point when the ship rotates in longitudinal direction. The ship rotates in longitudinal direction. The trimming moment is here, yeah? And the question is, what will be change of our trim after additional cargo has been loaded? I open the discussion. Who is the bravest one? Or in the meantime, who read notes, found out the formula? Maybe if I come back to the previous slide, and if we defined moment to change trim that is given in hydrostatic table, this is the number which is known in ship operation. Maybe the first formula, I will help you to some extent, will be you have to divide trimming moment acting actually on your ship by, who will say, moment to change trim. Yeah, do you agree? If you divide trimming
Yes.
moment that acts on your ship, it is that one, yeah, and you divide trimming moment acting on your ship by moment to change trim, you will obtain how much the trim will be changed. Okay, and what trimming moment is acting on our ship if additional cargo P has been loaded into ordinate XP and the ship rotates along center of flotation F. What will be the moment?
So we need to multiply our weight
Mm-hmm.
on the difference between the position of our weight XP and the position of the center of flotation XF.
Yeah, maybe I will put here LCF instead of XF. Do you know why? Because in your hydrostatic tables we use for our calculations during labs, the abbreviation of the center of flotation is LCF, longitudinal center of flotation. Yeah, this is that distance, LCF. And LCF, it is the same. I wanted to put XF. Yeah, but LCF is used in our hydrostatic table. So this is the reason why I put here LCF. And moment to change trim, MCT. Was it difficult? I hope not. It should be obvious for everybody. This is just repetition, yeah? What we said during last semester. If you want to calculate moment, you have to multiply force by a distance. Yeah? Force acting in a point of action xp, and which distance? Distance between point of action and point of rotation, so-called pivot point. Yeah? So the second degree of freedom is done. And the third one, change of the angle of heel. Who will propose the approach, method, formula, calculation of the angle of heel? Here, delta phi, yeah, caused by a healing moment. Usually we calculate in what way? Healing moment divided by displacement
and multiplied by GM.
By GM. Okay. And in our case, additional weight in transverse section. What moment is produced
P
by
times YP.
YP, and divided by
Displacement
actually,
plus P plus GM, the signature, yes. This.
Yeah, I will put here prime because after loading additional weight, GM is a little bit different than previously for the previous loading condition, initial loading condition. This is the only reason why I put here prime. Yeah, just to stress that after loading new cargo, you have new initial metacentric height. I hope you can calculate new initial metacentric height. The method is like that, am I right?
Yes.
Km prime from hydrostatic particulars, hydrostatic table. Okay. And kg prime, how can you calculate kg prime?
Displacement of the vessel times kg. No, just two weights we need to use. Yes.
Sum of statical moments divided by sum of weights. Yeah. Okay. I think it was the first lecture during the third semester. It seems to me, first or the second one. On the very beginning, we discussed the method of calculation of the position of the center of gravity. Kg prime.
Was first lecture, so.
Something like that. Okay. So the third degree of freedom is done. And I have to say this. If there is a student, anybody, who really did not know those three formulas, those three approaches, such student or such students, if the number is bigger than one, have homework to do. Not necessarily today evening, but in very close and very short time. You have to proceed. You have to proceed and to remember to understand different issues. If we understand such variables like TPC, if we really understand such variables like MCT, and if we really understand such variables like KM, those three formulas shall not be difficult for us. You should remember, you should understand these three formulas. 3 degrees of freedom. After additional weight has been loaded on board the ship changes mean draft, the ship changes trim, and the ship changes the angle of heel. And there is a great mistake here. Great mistake. And nobody said, I can see it now. I was too fast. Together with Batuhan. Batuhan, was it you talking with me about the third degree of freedom? Or anybody, or as a student, I'm not sure.
About the formula, I'm not. I'm just talking about the GM part and D plus.
Okay.
G.
Uh-huh.
After you write the formula,
Okay. So where is the mistake? The mistake is here. Yeah. It is not change of the angle of heel. This is tangent of the change of the angle of heel. So sorry for this. And I have to stress it in a way. Let's say I will shadow this formula using gray color. I was thinking about tangent of the angle of heel, but actually I put down on the slide change of the angle of heel. It is not true. It is tangent of this angle. Okay. So we did repeat a huge portion of the knowledge with regard to stability. What does it mean? TPC, MCT, GM. Okay. We noted the numbers actually are in ship documentation, in particular in hydrostatic tables. Okay. And then we used those variables for calculation of change of 3 degrees of freedom. Mean draft, vertical movement, delta T, trim, longitudinal movement, rotation actually, and the third one, angle of heel, transverse rotation. Yeah? Linear movement, delta T, and 2 rotations, delta T small and tangent of the angle of heel, of the change of the angle of heel. Okay, and these 3 formulas are very important for the next step for calculation what will happen to the ship if the ship is grounded. If the ship is grounded. So this is the reason why I spent together with you so much time on this issue, because it will be very important and we'll use this for further calculations. Okay, once again, if you need more time to repeat, to study these 3 formulas, please do it as a homework, preferably this week. Fine. Now let us go to the business. 1 hour passed. 1 hour passed, and now eventually we are at the topic. Okay. What event is the subject of this analysis, of our analysis? Okay, so not surprising to the topic, the ship is grounded. So I did put here a small heel. Sorry, I didn't want to do this. I wanted just to make a color. Yeah, a ground in red color, and there is a contact between the ground and the ship. Contact starting somewhere here and ending somewhere here. Area of contact between the ground and the ship. And of course, after grounding, the ship changed mean draft. Yeah, as a result of grounding, the ship changed mean draft for sure, changed trim, and changed angle of heel, change heel. And now I put here the situation like that. The pressure which is between the ground and the hull, there is a distribution of pressure. Yeah, this distribution of pressure I replaced by 1 force, and I call this is reaction. Yeah, this is reaction. So the force is acting upwards on the ship, on the hull, and there are two sections, longitudinal section. So I show you the force and point of action in longitudinal plane, how far the point of action of our force, imaginary force, is from aft perpendicular, it is xp, and the second drawing, how far is our force acting on the ship hull from the center line, and it is yp, xp and yp, yeah, and force itself. So the question is, after grounding, yeah, we know that the result of the grounding is change of the mean draft, trim and heel. What variables shall be calculated? And maybe you did catch the point. If I have to put a list of variables that shall be calculated after grounding, taking into account what have been said, what would be the list?
Sir,
Who
we
can
should
name?
calculate this reaction force. In order to calculate this reaction force, we need to calculate the new displacement and the new trim and the draft of the vessel.
Very good. But now let us focus on variables. So you told us that the first variable which is needed after grounding is reaction force. So N. Very good. The next idea you told us was how to do it. Yeah, how to do it. But
Yes,
let us continue the list. What else? I think that the next information, which is very important, is point of action. Do you agree?
Yes, but don't we know it already?
What?
Don't we know already the position of the action? I thought that we know that.
How can you do it? It is not possible. When you are grounded, the point of action is somewhere deep. So you will not dive and look for point of action. Yeah. Actually, this is not point of action. This is area. Can you imagine? This is area of contact.
Yes.
Maybe area of contact is 20 square meters. Yeah. But we assume for our purpose, for easy calculations, that area of contact, let's say 20 square meters, is replaced by 1 point. It means that pressure between the ground and the vessel is replaced by a force. Do you follow? Does everybody follow this idea? Actually, contact between ground and vessel, it is area. Maybe small, maybe large, I don't know. Nobody knows. Yeah? Area, and the real action of the ground onto the hull, it is additional pressure. But what we do to have simple calculations, we assume that area can be replaced by a point of action, and pressure distribution between ground and hull will be replaced by a force, one force. And force is abbreviated here as N, and point of action will be will be described actually by 3 numbers. If we live in 3-dimensional world, there will be 3 numbers describing position of the point of contact. So it will be xp, how far is point of action from aft perpendicular, yp, it means how far is point of action from the center line, and who is brave enough to say what will be the third, the last ordinate? Shall I put here ZP
baseline?
or? Yes, we will assume that the point of contact between ground and hull is placed on the baseline. So what will I do? I will delete ZP and put here 0. 0, it is the distance between the point of action and baseline. It means the point of action is assumed to be on the baseline. Not necessarily it is true, not necessarily. Sometimes if the point of contact is somewhere here, somewhere here, the vertical position of the point of contact may be non-zero, but for our purpose, we will assume that the contact point, the point of action of the reaction is placed on the baseline. This is assumption. Okay, this is assumption. So, how many variables shall we calculate?
3.
3 variables. So, how many equations do we need to calculate 3 variables? How do you think? Who is the best on mathematics? If we want to calculate 3 variables, so we need how many equations? Good question. It should be obvious for everybody. We will need
3 equations.
3 equations. 3 equations. And how many equations we were talking about 15 minutes ago?
3 exactly.
3, exactly 3. Change of mean draft, change of trim, change of the angle of heel. And please focus on these variables. I will take colors, change of mean draft, change of trim, and change of the angle of heel. Am I smart? Yes, I am. We are smart all together, yeah? We want to calculate 3 variables. So what is reaction and what is the point of action of such a force? We assume that the third ordinate is equal to 0. So we have 3 variables to be calculated. So we need 3 equations to do this. Okay. Now I turn to the group. So in my tablet, I switch the Moodle platform. You cannot see it, but I do it. And now I'm looking to your group, actually to abbreviations of your names. And the question is, does everybody follow the problem? Does everybody follow the idea? What we will do in the next turn as a next step? Did you catch the point? If not, please ask a question. I think it will be better if we discuss some things which are not clear now.
No, I didn't catch the point. Przepraszam.
Yes.
I didn't catch the point. For the assumption, you erase ZP and then you put 0 for the assumption. So I didn't get from that point.
I'm not sure I understand you.
Yes, from there, yes.
The question is, on the first turn, I wanted to put here ZP,
Yes.
as a third ordinate of the action point. So I will come back to this stage, ZP, and then I decided that the reaction force reaction force, the force that acts on our hull, is placed on the baseline. Yeah, is placed on the baseline. It is assumption. And what is the distance between the baseline and the baseline? The distance is 0. Yeah. XP, this is the distance of the point of action. I will put here A as a point of action between the point and aft perpendicular. So it is XP. Yeah. Here is point of action A. YP, red one, it is the distance between point of action A and the center line. And the last one, ZP, this is the distance between point of action A and the baseline. And if the point of action lies on the baseline, the distance between point of action and the baseline is equal to 0. So I did delete the ZP, and I did put here 0 as a assumption that we will not deal with vertical position of the point of action. Now I am not sure I did explain you the problem, the question, and still I am not sure who asked.
No, it is me.
Me, it is Mario.
No.
Nosakare. So, Nosakare, did I answer your question? If not, I will try to do it.
Yes, I understand. I understand XP from the point of action to the aft perpendicular, then the YP to the center line. But okay, now this one is for 0. The assumption is because it's from the baseline to the baseline, right?
Yeah, that's right. That's right.
Okay.
Exactly.
Okay.
I did assume that the point of action lies on the baseline, so the distance between point of action and baseline is equal to 0. So this is that's it.
Okay.
That's it. Fine. So actually we have to calculate three variables that will be needed for other calculations, like to the analysis of possibilities how to refloat the ship. But it will be the next turn. Now let us focus on the numbers, on variables. How to calculate such variables. For a moment, I will come back to the slide we discussed previously. Delta T, it means change of mean draft, change of trim, and change of the angle of heel. Yeah, using TPC, MCT, and GM. GM actually, in terms of hydrostatic table, it is KM. Yeah, one more player here is position of the center of gravity, vertical position of the center of gravity. And it seems to me that Batuhan or somebody else started to answer the question how to do it, and I will focus now on what data may be used for calculations. And the first package of data is the loading condition before grounding. This is the first package of data we can use. The loading condition before grounding. Okay, so the information: what is the weight of the ship, and what is the position of the center of gravity, G, X, Y, and Z in terms of kg, yeah, and gamma here stays as a specific weight of water, specific weight of sea water. Okay, the first package of the source of data, the loading condition. And I open the discussion, and probably it will be the last step today, because just 14 minutes ahead of us. I open the discussion. What can be calculated if we know displacement and position of the center of gravity, in terms, of course, change of draft, trim, and angle of heel. What can be calculated? And who wants to take floor and answer the question? What can be calculated if we know displacement and position of the center of gravity, namely, we know the loading condition of our ship before grounding? Who is brave enough, who is smart enough to answer such question?
Hello, sir. What's the
Yes.
question again, please?
What is the question? What can be calculated if we know the loading condition before grounding? Of course, in terms of draft, trim, and angle of heel. Do you agree that if we know our loading condition, it is possible to calculate what is fore draft, what is aft draft, what is port side and starboard draft before grounding? Do you agree it is possible?
Yes.
Yes, sir.
Yes.
We can calculate original ones, all of four of them. And then
Okay.
we could.
Just to speed up, I think that it will not be surprising for everybody. For draft, it will be mean draft plus trim, and there was length between perpendiculars minus LCF divided by the length between perpendiculars. Can you recall such a formula? You should. How to calculate trim? Trim, it is displacement, distance between the center of gravity and the center of buoyancy, divided by moment to change trim, MCT. Yeah. So if we know displacement, we may calculate fore and aft draft. Aft draft. TA, aft draft, it will be mean draft minus trim, and the relationship is here LCF above LPP. This is the knowledge from previous semester. I can remember I did encourage you to make such a drawing. I start to do such a drawing like that. Oh, I am in a hurry, so I will try to do it once again. The water line F LCF for perpendicular trim for draft, aft draft, mean draft, and so on. If you don't follow, if there are students who don't follow my drawing, a triangle here, actually there are three triangles. The first one, the second one, and the third one. Okay, and you don't see relationship between different distances here. Please do it when? Preferably this week or next week. Please refresh the memory and try to understand the drawing here. Different variables, relationships between distances, and final method, final formula for calculation of fore and aft draft. Mean draft, LCF, longitudinal position of the center of flotation, LCB, longitudinal position of the center of buoyancy, MCT, moment to change trim. Where is the source of data? All green variables may be read from hydrostatic table. Yeah. So coming back to the idea, if you know displacement and if you know longitudinal position of the center of gravity, and additionally you have hydrostatic table, you can calculate fore and aft draft in this loading condition, in your loading condition. Port side draft, how can we calculate? Who can remember what will be the formula? And starboard formula. I think it will be fruitful if it is homework for you. Homework to refresh, to remind how to calculate drafts in terms of fore, aft, port side and starboard side if the loading condition is known. It was the topic in December, if I remember correctly. Probably in December we started these problems. Okay, but nevertheless, it is possible to calculate drafts for numbers, aft, fore, port side and starboard side, if you know the loading condition before grounding. If you know the loading condition before grounding, for sure it is possible to calculate. There are 7 minutes ahead of us, and a lot of different slides. Maybe I will choose not the next one, but the slide which is main body of the presentation, main slide of the presentation, and I will focus, draw your attention to such way that if you calculate drafts before grounding, yeah, as a first package of data for your calculations, the second package of your data, second package of numbers, these are for draft, aft draft, port side and starboard side drafts after grounding. I will take pink color and show here after grounding. After grounding, you shall obtain somehow determine drafts for aft, port side and starboard side, and have the second package of data for calculations. The first one before grounding and the second one after grounding. And now, before we finish, I will raise the question: if you have two packages of numbers before grounding and after grounding, what can be done as the next step? How do you think? You have here formulas. We will discuss these formulas next time, so probably on Friday. If I remember correctly, we meet on Friday, so we'll continue. But let us open the discussion. What will be the next step? How do you think? If we have numbers in terms of drafts before grounding and after grounding, what may be done as a next step? Who wants to answer such question? I understand you are tired, maybe a little bit bored, but let us do the last turn today.
The next step may be to calculate the difference between the two drafts. I don't know if I'm right. If you have the draft one after ground.
Very good. The difference. I can see here not correct word. There should be change. Yeah, change. due to grounding. Change of what? Change of mean draft, change of trim, and change of the angle of hill. If we have data before grounding and after grounding, it is possible to calculate the alterations, the difference between initial state and final state. How the mean draft, how the trim, and how the angle of hill changed due to the grounding. If we calculate delta Tm, delta T, delta phi, what can we do as a next step? We can come back to formulas we started with and make an assumption. The force acting on our ship is not added weight, but it is external force caused by grounding. And use these three formulas we discussed previously for the purpose of calculation of N. N in terms of reaction between the ground and the hull. Okay. Back to the table here. Initial state before grounding, final state after grounding, change due to the grounding. Okay, we can calculate all of this, come back to formulas for change of mean draft, trim, and angle of hill, and where are the variables we want to calculate. The variables are hidden here. And we'll continue the discussion on Friday, how to calculate N, reaction, XP, longitudinal position of the point of action, and YP, transverse position of the angle of the action point. Okay, so this is the direction we will proceed with next time. It means on Friday. Now 2 minutes ahead of us, so I am back to this slide, and maybe somebody wants to ask me a question before we stop, before we finish. If there is a student, please do it.
Hello, sir. On the formula on the next page, you put something like LPP. What is that, please? LPP, I don't know. Yes.
Here.
Yes. Yeah. What is that?
This is length between perpendiculars. LPP, it is length of our ship from aft perpendicular to forward perpendicular. Sometimes they use LBP, length between perpendiculars. I used LPP. It means length of our ship from aft perpendicular to forward perpendicular. If I have to show on the screen, this is that distance from aft perpendicular to forward perpendicular. I wanted to make it more clear. Okay, LPP, length between perpendiculars. I hope, I'm not sure, was it God's Power asking the question? God's Power?
Yes, sir, it was God's Power.
Yeah. Okay, so I hope you can see that length between perpendiculars make here relationship between triangles. I started to show you red triangle, blue triangle, and green triangle. Tangent of the angle of trim. I will put this abbreviation here. C. This is T over LPP, but at the same time it is, I will put here TR over LCF, and at the same time it is, I will put here TF, it is TF over LPP minus LCF. Okay, this is pure geometry I put here. This is pure geometry. Similar triangles, and I hope God's power, you can transverse this geometrical relationship into final formulas how to calculate fore and aft draft. Maybe you can see LPP minus LCF over LPP. It will work like here, like this. And I can encourage you and everybody to take just a blank piece of paper, maybe pencils colored into blue, green, and red. Mark triangles I'm talking about, mark all the distances and angles, and develop by your own the formulas of calculation of fore and aft draft. I'm serious now. I do encourage you to do this as a homework, just for your professionalism, for your experience, and to study, yeah, and just to study relationship between different variables. LPP, God's power, and anybody else. LPP, it is length between perpendiculars. Length between perpendiculars. So if you work on board the ship which is 100 meters length, so LPP, it is 100 meter. Now, God's power, do you understand this variable? Distance?
Yes, I understand. It relates to like the length overall of the ship.
No, it is not length overall. This is length between perpendiculars. So the transom at the aft is ignored here, and the bow is ignored. Yeah, can you see?
Yes, I understand. I can see. It's just between the perpendiculars and not the full length of the ship. I understand.
No. Because the drafts are taken on perpendiculars. These are artificial lines, yeah? They don't exist. But if we calculate fore or aft draft, we usually calculate it for perpendiculars, for spatial places in the reference system, yeah? Spatial places in the reference system. LPP, it is length between perpendiculars, not length overall. Okay. What shall I do now? I switch off the recording.
Sir, and I have like the last small question, okay?
Yes, please.
And
please
what is LCB? Is it longitudinal center of buoyancy?
Yes, it is longitudinal center of buoyancy. So yes. I should take a color and put here somewhere center of buoyancy, yeah? And LCB, this is the distance between the center of buoyancy and aft perpendicular. It is LCB. The picture here drawing is very small and too many variables, too many distances marked on it. But let's say your imagination was correct. LCB, it is the distance between the center of buoyancy, B, and aft perpendicular. LCB, it is longitudinal center of buoyancy. LCF, it is longitudinal center of flotation. Yeah. So F is here on the water line. B is somewhere underwater, beneath the water surface. Yeah, deep. Let's say how deep? More or less half of the draft. Yeah, more or less half of the draft. Fine.
Okay, sir. Thank you.
Thank you. So it seems to me that now it is time to switch off the recording, so I will do it. And we will continue the topic on Friday. So don't be, how to say, don't worry, yeah, don't worry. We'll come back to this topic on Friday and continue all the variables. So if in the meantime you want to ask me a question, please note the question and ask this on Friday before we start calculations. Okay.